Decentralization Media.
Hi, I am Mr. M. In this video, what we are going to look, it's about what is blockchain. The last video we looked about what is blockchain in a theoretical way, and in this video we will look more in depth about what is blockchain and how it works. So let's move into the topics. Before moving much depth into blockchain, we need to understand two things. One is hash function and other one is ledgers. The hash function is a function that you can put any type of input that will be transformed that input into a string that contains characters and numbers. So the string that is comes as we call as hash value, and this hash value you can't able to read or you can't able to understand this value, but it's just a random numbers and the random characters that forms a string that you can call it as a hash value. The length of the string will be differs based on the hashing algorithm that you are using, and in this process we used SHA-256 hashing algorithm, and that is the same algorithm used by Bitcoin blockchain as well. The best part of the hashing algorithm is when you have a small change in this input that you are providing, then that will be convert that into a hash value that will be totally a unique one. So you can, in these two examples, like we change the capital A into a simple A, and you can't compare and understand like what is the difference happens in that hash values, because both are totally comes as a unique values. So that is the best part of the hashing algorithm. When there's a small space or even a character change or even a small full stop happens, the value will be changed totally. And it's all not only about string values, so you can hash any type of a documents or any type of images or any type of music files into a hash value, and that will be create 64 byte characters. In case of if you're using SHA-256, it will be create a 64 byte of byte length of the character string that will be contain characters and the numbers. And the other important part of the hashing algorithm is it's a one-way function where you can put an input and you can get a hash value, but you can't put the hash value and you can get the input. So it's totally anonymized way if you're using the other way around. So you can put whatever the input you want and you can get a hash value, but you can't put the hash value and you can get the actual input that you provided in the start. And the second part is we need to look about ledgers. So the first type of a ledger is we will be look about centralized ledgers. So in the centralized ledger, for example, if we have like four branches of a bank and they are using a centralized ledger. So in this centralized ledger, we can compare this as a ledger, or else we can compare as a centralized database. So if you are in talking about centralized database, what happens is each of these branches will be make their own transactions, and those transactions will be go and update in that centralized database. The issues of the centralized database, it's a single point of failure because there's only one database and all these branches accessing that one. So in case of that database is failure, or else if some hackers went and hacked this database, then what happens is all these branches cannot make any transactions or cannot record any, because they all depend on that one single database, and that is called single point of failure or single point of attack. And the other way, like even if a hacker wants, they can easily go and change whatever they want in that single database, because once they make an update, that will be appeared in all the branches and they will be follow the same thing. To avoid these issues, there's another ledger that we are using, mostly a distributed ledger or distributed database. We are couple of branches will be hold the databases, and other branches will be updated to that. And this is the same process that we used in the Facebook and Google as well, where we have different regions they store as a data warehouses. So each region will be store data, and they'll be sometimes replicate or sometimes shard databases. But once there's a one region is down, still Facebook can work, and because the other region database can connect with the users and they can work same as what they used previously. But still there are some issues, because still these data are stored in a limited amount of regions, like for example like 5 or 6 regions. Still if someone wants, they can hack this one, they can make it down, and even if they want, they can go and change couple of data in multiple regions as well. So those possibilities are there. And the third one is like the decentralized ledger. So that is the way that a blockchain works, where each branch will have their own database or own ledger, and then they'll be update their data into that ledger, and the same time they'll be communicate that with other branches as well. And at one point of a time, all the branches will be have the same version of a ledger or same version of a database, where all the transactions that each branch has made will be updated in other branch databases or ledgers as well. So if someone want to hack these branches or hack these databases, then they need to hack it in all the places, or else they need to hack at least, or they need to make it down at least 51 percentage of the, or 51 percentage of the branches. So that is very difficult and time consuming as well. And the same time, even if one branch is hacked or down, then other branches can even easily get it now, because their versions will be not matched. And the same time, once one branch is down or else one branch is failed, then the other branches can work without that dependence of that branch, because they have their own ledgers and they can make transactions based on that own ledgers, and they can get approved by other branches as well. So this is how the blockchain mechanisms works in a decentralized way. And this is another way that we can look into those three examples that we mentioned, like centralized, decentralized, distributed in a network scenario where in centralized all the nodes, all the machines that will be pinged to one of the central point, and there's a central point of failure will be there. That is the main issue. And in the distributed ones, we are connected still, but there is a limited amount of nodes that we are connected, and still there can be failures and hacks can happen. But in if you are looking to the decentralized way, there's totally a decentralized, and there's no point that we can hack that one single point or else one couple of machines and make it down the system. And if you look in another way, like blockchains, each block will be contains a limited amount of transactions, so based on the time the blocks will be created, and each blocks will be comes and joined with the last block that is previously mined. So these blocks will be created in a mechanism called mining, and we'll be look that into a next video how this mining process works in more depth view. For now, just to have an idea that each block will be created based on a mining mechanism, and that mining mechanism is a mathematical mechanism where multiple people will try to compete, and who is the one finding first the answer will be create that next block, and they will be get the mining rewards as well. And it's the same process as the ledgers as well, the traditional ledgers where we'll be write the records next after the last record that written, and still we cannot go and write the records after one or two rows after that, or else we cannot go and change it in the middle as well. So that is how the blockchain also works, where we can add the blocks next to the last block, and we cannot skip any blocks and edit, or we cannot go in front and we can change the records in the previous blocks. And the each chain will be built based on the hashing mechanism, where we seen the same hashing SHA-256. So all the transaction that we are inside in the block, so apart from the transaction there will be other additional informations as well, like timestamp, previous hash values, and all those informations, and they combine all these informations and they put it in the SHA-256 hashing algorithm, and they'll be create a hash value. So this hash value is, as mentioned, is a unique one, so it's like a fingerprint for that block, and that fingerprint of the block will be connect with the next blocks as a previous hash. So the next block will be include that previous block hash value as a previous hash, and they'll be make the links based on that. And in this mechanism, when there's someone go and change simple value or something inside a previous block, for example, if they are make $100 transactions, and if they go and change that into $1,000, then that hash value will be changed, because as I mentioned, if you are making a small change, the hash value will be differs. So if they make a small change in a one transaction, then the hash value will be changed, and that will be effect in the next block, because that is referred that hash value as a previous hash. So the link will be break there. So when there's someone want to hack this blockchain mechanism, what they want to do, it is like they need to change this one block, and then they need to change the next block as well. Likewise, they need to change other blocks, because each 10 minutes in bitcoin mechanism, bitcoin scenario, each 10 minutes there will be a new block created. So each 10 minutes there will be new blocks comes, and they need to update these previous blocks before next 10 minutes, and they need to go and change it in another block as well before the another 10 minutes. So that is very time consuming and computation power process that you need to do to hack this blockchain scenario. But even if you hack this one, still you are hacking your own ledger. That means that there are other users ledgers will be there, and that won't match with your ledger. So you need to at least make this change in a 51% of the users node. So that is nearly impossible, and still there's no one done that process from 2009 to 2020. Still there's no one done that process, because that is very difficult and time consuming, as well as that is very costly as well. And the way that records or the transactions are that stored inside the blocks, it's called Merkle tree. So in the Merkle tree, where the base layer will be, it's like a binary tree where the base layer will be stored all the transaction in a raw format. So in here we are getting example as 4 transaction were stored, and it will be go through each transaction will be go through a chart of access hashing format in terms of a bitcoin blockchain, and they'll be convert these transactions into a sha 256 hash value, and then they'll be combine two of these hash values, and they'll be append those two hash values, and they'll be again put in the chart of access, and then again they'll be create a new hash values. Likewise, they'll be build this tree kind of a structure, and until they find the root merkle root. So the top part that contains mk and 01, so that is the one called as merkle root, that is the top part of that, and they'll be build this tree until they find the merkle root. And what is the benefit of this merkle tree is like when there's someone go and change one of the transactions, then actually the hash value will be changed, because as I mentioned, if there's small change happens, the hash value will be changed. And once they change this hash value, then they need to change the next layer as well, because that is that those two values are appended together and created that value. And same as they need to change the merkle root as well, and this merkle root value will be go and stored as a one parameter inside the block hash. So when you're creating that block hash or block fingerprint, this merkle root will be goes as a one value. So once someone changes one transaction, then they need to change, build this trade chain, and they need to update it until the Merkle root. And then once they update in the Merkle root, that they need to go and update the block hash as well. So once they change this block hash, then they need to change the next block, because that is referred this block as a previous hash. So likewise, they need to change every block that is referring as a previous hash. So that is one of the secure way that blockchain storing these transactions, and blockchain maintaining this security as well. And in here it looks like very easy, because we are only mentioning about 4 transactions, but in a Bitcoin blockchain, within 10 minutes there will be 10,000 transactions. It becomes, sometimes it becomes more than that as well. So storing all these 10,000 transactions and updating this Merkle tree, that is very time consuming and computationally very costly effect as well. And the way that blocks are distributed in the blockchain network is like, it's comes from a process called mining. As I mentioned, the block will be created, and who is the one doing this mining process will be called as miners. And once the miner was created this block, then that will be passed, that miner will be passed that at that block in their chain, and then that will be passed to all the other users as well. So when it's going to all the other users, and they will be validated, that one they will be added with their chain. So once this updated with multiple users, and once this was get as a valid block, then the miner will be get a rewards, and the blocks will be updated, and the next mining process will be start. So this is the way that blocks distribution happens, and we'll be looking to the next video how this mining process works, and in depth how this mining works, and how these miners works, and how these mining pools are working. So we'll be look those into a next video. Thank you guys for watching this video, and please mention your questions in the comment sections, and do subscribe our channel and click the bell icon for future videos notifications. Thank you.
Decentralization Media.